Assalamualaikum warahmatullahi wabarakatuh. My name is Mohamad Fathi Yakan Zulkifli. Material number D170034. So this is my team member Rahmat bin Buserah and Mohamad Faizol bin Ismail. So for assignment number 2, visual system, the topic is recyclable material classification by using convolutional neural network. So introduction. Recycling is important in today's world if we want to leave this planet for our future generation. It is good for the environment since we are making new product from the old product which are of no use no use to us. Now many landfills are closing because there are no more room effect when no recycle. So from this we can do that the public awareness for the recycle is still low. So to help reduce the landfill from full, so we will do the some system to classification by using convolutional neural network of the waste. So for this assignment, we do three methodology. So first we do the convolutional neural network. A convolutional neural network is a deep learning neural network that takes an image as the input, then assign weight and bias to various features in the image. Through a learning process, the weight and bias are refined and sections of the image are future process. The CNN eventually differentiate the feature within the image from one another. Convolutional neural networks have been used by other researchers to analyze the digital image for object recognition or classification. So this is the feature detection and classification layer in CNN. So first we the feature detect the image, and then we classify the from the image. Then a second method is ResNet 50. Just like Inception v3, ResNet 50 is not the first model coming from the ResNet family. The original model was called the Residual Net or ResNet and was another milestone in the CV domain back in 2015. The main motivation behind this model was to avoid poor accuracy as the model went on to become deeper. So this is the ResNet 50 model. So this have a 5 stage. Okay. So this is input 0 pad. So we go through the 5 stage and then we go to the output. So the third method is a very deep convolutional network of large scale image recognition, or we call it VGG16. The VGG16 is one of the most popular pre-trained model for image classification. Introduced in the famous ILSRVRC 2014 conference, it was and remains the model to beat even today. Developed at the Visual Graphic Group at the University of Oxford, VGG16 beat the then standard of AlexNet and was quickly adopted by researchers and the industry for their image classification tasks. So this is the layout of the VGG16 model. So they have 13 conv, 5 layer of pooling, and 3 layer of the dense. Okay. So for this assignment, I will do the demonstration for the task 1. So first we connect. Okay, then in setting we take the GPU. Okay, so this is the coding. Okay, copy. Yes. Okay, connect to the Google Drive. Okay, so click this link. Okay, take our Google Drive email. Okay, copy, and then we put at this box. Okay, enter. Okay, done. Then we import to the folder. Then we go to the image where the file save. Okay, so make sure the name of the folder is same like at the folder we write it. Okay, we can check at here. Okay, my drive same, so go to G drive and notebooks. Okay, dataset. So this is the file. Okay, next the output of this coding. Can train length, page train length, can fill length, and page and fill length. So then for the next. Cool. So this is the layer, and there are output shade, and there is a parameter value. Okay. So next. So this is the code for produce the graph. So we can see for at the graph the optimum or not. So I will try to use 100 images to get the smooth graph. Okay, we run. So we wait. So when we use the GPU, the result will get faster. Okay. So we wait first. And finally, this is the result. Okay. Found 466 image belong to class. Found 210 image belonging to class. So this is the value for the loss accuracy validation, loss accuracy. Okay. So we will look at the graph. Okay. So this is training and validation accuracy and training and validation loss. So at the Google Colab, when we try to make the different graph with the different approach, the graph will be different, but when we back to get the same value of epoch like previous, so the graph will be different. So I will take this graph as the my output. So then we try to detect the three sample image. So this is the my sample image. So the three images have a different position. Okay, so we want to try to detect the aluminium and mineral water. So this code. Okay, copy. Okay, to run. Okay, so wait. So this is the result for the three image. So from the three image, uh, from this graph can detect 100% is a PET is a aluminum water. So from get the perfect of the result at here. So the graph must be the optimal and osmos and optimal. That's all from me, Doctor. Thank you.
Assalamualaikum. My name is Mohamad Faizol Ismail. So I'm going to continue our presentation by explaining the second pre-train that we choose for image recognition. So the pre-train model that we use is a Visual Geometry Group (VGG) 16 model. So this is a model structure for VGG 16. So VGG16 is convolution neutral network that is 16 layer deep. So in this task, by using transfer learning concept to start the training process and find the optimal model for the data set given. So the data set given is can and the 1.5 bottle. So this is the testing result for training and validation graph for VGG. So for this, I'm using the epoch equal to 29, 30, and 35 to find the uh, optimal training and validation accuracy. So when I'm using the epoch equal to 29, the graph for training and validation accuracy and training and ventilation loss is overfitting. So you can see the line. So when I'm using the epoch equal to 35, so the graph is underfitting. So the optimal value for the training and validation is 30 when I'm using epoch equal to 30. For this training, I am using batch size equal to 8. So the next slide is this is the training result of VGG16 model with 1.5 liter PET bottle and aluminum can. So this is the result for the PET bottle and aluminum can is side by side. So when I training the coding, the position of 1.5 PET bottle and aluminum can are side by side. The printed result show the image for aluminum can is 0%, and for the 1.5 liter PET bottle is 100%. So this is for when the PET bottle is at the front and the aluminum can is backward. So the printed result show the image for aluminum can is 0%, while the value for 1.5 liter PET bottle is 100%. So this is the last one when the PET bottle is backward and the aluminum can is remain at the position. So the aluminum can is 100% while the value for PET bottle is 0. One is I'm going to connect the Google Drive to the Google Collab, which is I'm going to copy paste my coding. So I'm going to run. So the Google Drive, the dataset is connect to the Google Collab. So the next one is I'm going to feed dataset directory, which is I'm going to use my link to this code. So you can see the Collab notebook and dataset is already import into the Google Collab. So the next one is I'm going to create train and validation data directory. So I'm going to use new code and then I'm going to copy paste my code, run. So it takes some time. So successful. And the next one is I'm going to construct the pre-trained model using VGG. So I'm going to import a TensorFlow. So I'm going to new code and copy my coding and run. So the downloaded data from the TensorFlow is successfully, and then I'm going to start the pre-process the input data. it shows here. And then I'm going to rescale all image and set the bench size and target size. So I'm going to use target size 150 and 150, and the bench size is 8. I'm going to run. So it show the code. It has found the image from the dataset. So the next one is I'm going to the training process. So here I'm going to use epoch equal to 35. So I'm going to run. After the training is done, so you can see the epoch have successfully running. And then I'm going to plot the graph by using this coding. And the result is the training and validation accuracy. You can see here is the result is under fitting. So from the training for the VGG from my testing, so I found out that 30 value for epoch is very good for the graph, which is the optimum of value for this training. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rahmat bin Buserah. My metric number is CE170097. Today I will present the recyclable material classification by using ResNet 50 convolution neural network. So here a little bit of introduction. ResNet 50 is a variant of ResNet model which has 48 convolution layer along with one max pool and one average pool layer. It has 3.8 times 10 to the power of 9 floating points operation and have 15 layers, able to train more than 1 million images from the ImageNet database. So this is the here is the model for the architecture of ResNet model. So it contain 50 layers for the total, and the first one is 7 times 7 convolution. And the third layer, the second layer is 3 by 3 max pooling for the max pooling layer. Right, this is the image that will be tested in demonstration later on. The first image is can and bottle is at the same position, and the second image is the cat at the front and pet at the back, and then the pet is at the front and the cat is at the back. So the three type of image will be tested in ResNet 50 convolution. Okay, here is the demonstration of ResNet convolution in Google Colab. Assalamualaikum warahmatullahi wabarakatuh. My name is Rahmat bin Buserah. My metric number is CE170097. Okay, today I'm gonna explain the ResNet retrain using task 2. So step 1, I have mount the Google Drive with Google Colab, and step 2, fit data set factory. And step 3 is this is my path. So here is my path for the folder test, train and validation. This is the structure of the reasoning model. So the trainable parameter. So step 5 you pre-process the input from class. And then step 6 start training process. My approach value is this is the optimum value that I have test. Step 20 step per approach is 4 and approach is 20. So the graph shows like this. So almost the result shows the optimal value is almost achieved. So the difference with validation accuracy is about 2 point. Okay. So for the accuracy training is optimal value compared to the test CNN test here. So the CNN test is more optimal because CNN value have we call the accurate approach number. So for ResNet they are a little bit different here because the validation accuracy is not in the training accuracy graph, training accuracy area here. So what can I conclude in this post training is the CNN training is more optimal value compared to the ResNet training. And then the ResNet training is more time to running it. So in order to train the fast training, CNN training is more faster and compatible. So that's all for me. Thank you.
So this is the result and analysis. So I will present for the task 1 CNN. Based on the first graph is training and validation accuracy. So training accuracy is a constant value, but validation accuracy is some noise. Okay, same as the training and validation loss. So training loss is constant, not have a error loss, but validation loss have some noise. So this we can say that the graph is overfit. So this we take test for 3 sample of the image with the different position of the pad and a can. So the result is for the 3 image 0% for a can and 100% for the pad. So this is because of this graph is not optimum, so not get the overfit. Okay.
As a conclusion, a material or object classification problem can be addressed by using convolution neural network (CNN). So CNN can be designed to train the data, which is in this project we have developed our CNN model. So the next one is by using transfer learning concept, the CNN can be combined with the pre-trained model to improve the accuracy of the data classification. So in this task, we have choose two pre-trained model, which is ResNet 50 and VGP60. So the ResNet 50 model achieved the best result for height training and validation accuracy. And as the final conclusion, ResNet 50 model can be the best pre-trained model for image classification.